Welcome to the Explainer. Today, we're jumping into a really cool evolutionary puzzle inspired by a lecture from Stanford. And the question is this: can the secrets of a species' entire social life be written in its bones?
Okay, let's just dive right in with a claim that sounds, well, kind of impossible. Picture this. I hand you just two skulls, one male, one female, both from the same species. Could you really figure out their entire social world just from that?
So let's set up a little comparison. You've just discovered two new species. Now, for species A, the male skull is way, way bigger than the female's. But for species B, their skulls are pretty much identical. And that's it. That's the only clue you get. And yet you can. That one little clue is enough to start predicting a whole bunch of stuff. Their aggression levels, how they choose mates, who takes care of the kids, even who's more likely to cheat. It's wild. But to see how this all works, we've got to first unlearn a really popular myth that I bet most of us heard growing up. Yeah, before we can get to the real rules of the game, we have to toss out this old, kind of comforting idea that you've probably seen in nature documentaries for, forever. We've all heard this one, right? This idea was made super popular back in the 60s by a zoologist named Wynne Edwards. It basically says animals do things, even make sacrifices for the good of their whole group. Sounds nice, but the problem is it's almost totally wrong. See, this idea of group selection, it's been pretty much debunked, and here's why. Think about it. If there's one individual who cheats the system, who acts for their own good instead of the group's, they're going to leave more kids and therefore more copies of their selfish genes. Over time, that's what's going to spread. You know that classic story, right? A herd of wildebeest, a dangerous river full of crocodiles, and one old heroic wildebeest just leaps in, sacrificing himself so everyone else can get across safely. It's a great story, except it's not true. When biologists actually watched what happened, they saw something totally different. The old guy didn't jump. Nope, he got pushed from behind. So if animals aren't acting for the good of the species, then what on earth is driving their behavior?
Well, the answer comes down to three basic building blocks. This is really our toolkit for understanding how pretty much all social behavior evolves.
And this is the first and maybe the most important shift in thinking we have to make. Evolution isn't really survival of the fittest. It's actually about the reproduction of the fittest. The real prize, evolutionarily speaking, isn't just staying alive. It's making as many copies of your genes as you can for the next generation. Okay. So the first and most obvious way you do that is through what we call individual selection. Basically, you do things that help you reproduce successfully. You are the one passing on your genes directly. Simple enough. But there's another way. That's our second tool, kin selection. You share genes with your family, right? So another strategy to pass on your genes is to help your relatives survive and have kids of their own. And of course, the more closely related you are, the more genes you share, and the more evolutionary sense it makes to help them out. The geneticist J.B.S. Haldane summed up the cold, hard math of this perfectly with this famous quote: "You share half your genes with the brother, but only an eighth with a first cousin. So, from a genetic point of view, 2 brothers or 8 cousins equals you." So what about helping someone you're not related to? Well, that's our third tool. Reciprocal altruism. This is the whole "I'll scratch your back if you scratch mine" idea. It can be an incredibly successful strategy, but it has a huge catch. It only works if you can spot the cheaters and punish them for taking advantage of you. And this creates this constant tension, what game theorists call the prisoner's dilemma. Should you cooperate and get a pretty good shared reward? Or should you cheat? You might get a huge payoff for yourself, but you also risk getting totally burned if the other person cheats too. So what's the best long-term play here? Well, people have run millions of computer simulations to figure this out. And the winning strategy is actually beautiful in its simplicity. It's called tit-for-tat. You just follow 4 simple rules. Start by being nice. If you get cheated, you retaliate. If they go back to being nice, you forgive them. And fourth, make sure your strategy is crystal clear. You're nice, but you're no pushover. All right, so now we have our toolkit, right? Individual selection, kin selection, and reciprocal altruism. Let's go back to our two skulls and see how these ideas solve the puzzle we started with. Because with just that one single clue, the difference in skull size, and these three principles, we can now predict two totally different social worlds. And here it is. This is the reveal. On one hand, you have tournament species where males are huge and they compete like crazy. On the other, pair bonding species, where everybody's about the same size and cooperation is the name of the game. And look how everything else just flows from that one difference. Aggression, who raises the kids, what females are looking for in a mate. It all just clicks into place.
Let's break down the tournament species. Think savanna baboons. The males are basically built for one thing: fighting. All their energy goes into getting big and aggressive to win mates. The females, they get zero help raising the kids, so their best bet is to just pick the winner of the tournament, the guy with the good genes. And since she's on her own, she can really only afford to raise one baby at a time.
But then you have the pair bonding species, like marmoset monkeys. Here, males and females are a team. Males aren't being selected for their fighting ability, they're being selected for being a good dad. And because you've got two parents sharing the load, suddenly it's possible to raise more kids at once. So you see a lot more twins. It is a totally different way of life. This whole framework is just incredibly powerful for making sense of the animal world. But you know what's coming, right? It leads us to one final and pretty irresistible question.
So when we turn this exact same lens back on ourselves, what do we see? Are we a high-stakes, competitive tournament species, or are we a cooperative pair bonding one?
And the really fascinating answer is, we don't fit. Not neatly, anyway. We're not a classic tournament species, and we're not a classic pair bonding species. On pretty much every measure you look at, from body size to who raises the kids, we are just kind of stuck right there in the middle. And maybe, just maybe, it's that biological confusion, that constant push and pull between two totally different strategies that explains the beautiful, the complex, and yeah, the often maddening world of human relationships.